Good day, everyone. Today, I'm going to discuss the distance formula. Let us get to know first the following objectives. At the end of the lesson, you should be able to: number 1, determine the distance between 2 points, and number 2, applies the distance formula to prove some geometric properties. The distance formula: d between any 2 points A represented by x sub 1, y sub 1, and B represented by x sub 2, y sub 2 is given by the general formula d is equal to the square root of the difference of the squares of x sub 2 minus x sub 1 plus the difference of the squares of y sub 2, y sub 1. As a proof, draw an auxiliary vertical line from point B, which is x sub 2, y sub 2, and auxiliary horizontal line from A, represented by x sub 1, y sub 1. The intersection between the auxiliary lines is what we call as C, which is represented by x sub 2, y sub 1. From the figure, we see that the distance between B and C is y sub 2 minus y sub 1. The distance between A and C can be solved by getting the difference of x sub 2 minus x sub 1. To find the distance between A and B, we are going to use the Pythagorean theorem. So that is equal to d squared is equal to the square of the difference of x sub 2 minus x sub 1 plus the square of the difference of y sub 2 minus y sub 1. And once we extract a radical sign or square root, we have come up with the general formula, which is equal to d equals the square of the difference of x sub 2 minus x sub 1 plus the square of the difference of y sub 2 minus y sub 1. Let us take a look on our first example. Find the distance between A, represented by negative 2, 5, and B, which is represented by 4, negative 3. So we can let A, which is represented by x sub 1, y sub 1 by its given, as well as B, which is represented by x sub 2, y sub 2. Applying the distance formula, we're just going to substitute the values from the given. So we have d is equal to x sub 2, which is equal to 4, minus x sub 1, which is equal to negative 2 squared, plus the square of the difference of y sub 2, which is equal to negative 3, and y sub 1, which is equal to negative 5. So we have come up with d, which is equal to 6 raised to 2 plus negative 8 raised to 2. D now becomes square root of 36 plus 64. D is equal to square root of 100. And from that, we have come up with D, which is equal to 10 units. For our second example, show that a triangle with vertices J, 3, negative 2, H, negative 2, negative 7, and O, negative 3, 6 is an isocline triangle. So from our example, we have a given such that triangle JHO has sides segment JH, segment HO, and segment OJ. So we're trying to prove that segment JH is not congruent or equal to segment HO, as well as it is not also equal to segment OJ. So of course, we need to solve for segment JH by using the coordinates of J and H. So we have square root of -2 minus 3 squared plus the square of the difference of -7 minus -2. So we have the square root of -5 squared plus -5 squared. JH now becomes square root of 25 plus 25. JH is equal to 50. And of course, we are going to extract a square root and get its perfect square from the factors. And we have come up with JH is equal to 5 square root of 2. Same case applies for segment HO. Using the coordinates of point H and point O, so we have segment HO is equal to the square of -3 minus -2 plus the square of 6 minus -7. It will come up to the square root of -1 squared plus 13 squared. Segment HO becomes 1 plus 169. Segment HO is equal to 170. And now, to solve for segment OJ, we're going to use the coordinates of O and J, which is -3, 6 and -3, -2. Applying the distance formula, we have segment OJ is equal to the square of 3 minus -3 plus the square of -2 minus 6. OJ becomes the square root of 6 squared plus -8 squared. Segment OJ is equal to the square root of 36 plus 64. Segment OJ is equal to the square root of 100, and getting the square root of 100, segment OJ is equal to 10. So since from the solutions that we have solved, we have come up with segment JH, which is equal to 5 square root of 2, segment HO, which is equal to square root of 170, and segment OJ, which is equal to 10, then we have come up and we have proven that segment JH is not equal to segment HO, and it is not also equal to segment OJ. We need to also keep in mind that in proving some geometric properties, the distance formula may be used together with other geometric formulas, such as the midpoint formula and the formula for the slope of a line. Check the box below to recall these formulas. So for the midpoint formula, given x, y, so we can solve it by getting the sum of x sub 1 plus x sub 2 divided by 2 for the first coordinate, and we have y sub 1 plus y sub 2 divided by 2 for the second coordinate. And recalling the formula for the slope of a line, so we have m is equal to y sub 2 minus y sub 1 is equal over x sub 2 minus x sub 1. Let us take a look at this example. Find the midpoint between the line segment joining 1, 5 and -7, 9. So using the midpoint formula stated earlier, so we have now x, which is equal to x sub 1 plus x sub 2 all over 2 becomes 1 plus -7 over 2, that is equal to -6 over 2, that results to -3. For y, we have y sub 1 plus y sub 2 all over 2, that is equal to 5 plus -9 all over 2, that is equal to -4 over 2, and that results to -2. So therefore, the midpoint of the line segment is -3, 2. Let us take a look at example number 4. A quadrilateral whose vertices h, which is represented by -4, 4, o, 3, 9, m, 8, 2, and e, 1, -3 is a square. Is it true or false. So first, we need to identify the segments of the given quadrilateral. First, we have for segment HO, using the vertices of H and O, applying the distance formula. So we have segment HO is equal to square root of 74. Next, we have for segment OM, using the vertices of O, which is 3, 9, and M, which is 8, 2. So we have come up with segment OM, which is equal to square root of 74. And now for segment ME, using the vertices of M and E, applying distance formula, so we will get segment ME, which is also equal to square root of 74. And for segment EH, using the vertices of E and H, applying the distance formula, we will also get segment EH, which is equal to square root of 74. Since all the segments are equal, then the given figure is a square. Therefore, it is true. And by that, thank you class for listening and see you on our next lesson.